Hi everybody, in this video we're going to go over test number 2. So in the first question we have a right triangle and we're given two sides of the right triangle. We have to find the last side. So we're going to use Pythagorean theorem to do that. So we're finding the hypotenuse. So we are looking for what C is, and our A squared and our B squared are 30 squared and 75 squared. So typing this into my calculator, I'm typing in 30 squared plus 75 squared, and I got 6525 for C squared. Now we just need to solve by taking the square root of both sides. I'm going to do that in my calculator. I'm going to take the square root of 6525, and I get 80.777, which to the nearest foot rounds to approximately 81 feet. So there are approximately 81 feet from pole 1 to pole 2. Okay, for number 2, it's talking about triangle ABC, but I don't see a triangle here, so I'm going to draw one. I also notice it says that angle C is 90 degrees, so I have a right triangle here. So I'll make this one A and this one B. C is the right angle here. If AB is 5 and AC is 4, which statement is not true? So I have two sides of my right triangle, and before I start looking at which is true, the sine, cosine, or tangent ratios in each of the answer choices, I'm just going to find this last side over here in case I need it. So 5 is the hypotenuse. So when I plug into the Pythagorean theorem, let me give myself a little bit more space. I'm solving for one of the legs. So I'm going to make sure 5 goes in for the hypotenuse. Okay, so the legs of this triangle are 3 and 4, and the hypotenuse is 5. Let's check out the answer choices. So let me write down my SOHCAHTOA. So in answer choice 1, we're focusing on angle A. From angle A, cosine would be A over H. So here's opposite, here's adjacent, and here's hypotenuse from angle A. So that would be 4 over 5. That is true. We're looking for the statement that's not true. So this is not the answer choice that we're looking for. Moving on to number 2, once again, we're still focusing on angle A. We're talking about tangent. Tangent is O over A. So from angle A, here's opposite, here's O. So opposite over adjacent would be 3 over 4. So once again, that's all good to go. That's correct. It's not the choice we're looking for. Let me reset, because for the next answer choice, I already see we're focusing on a different angle. We're focusing on angle B. So from angle B, this would be opposite, adjacent, and hypotenuse. So sine is O over H. So sine of angle B would be 4 over 5. So that is correct. And then finally, tangent of angle B. Tangent is O over A. O is 4. A is 3. That's not this. This is 5 over 3. So answer choice 4 is not a correctly set up ratio. That is the correct answer here. It is not true. Okay, so we're talking about two triangles here. Well, triangle ADE. But in triangle ADE, we know that BC is parallel to DE. And remember, if we have a triangle that has a segment parallel to the base, it creates two similar triangles. The small triangle is similar to the big triangle. Keep in mind, similar triangles have congruent angles and proportional corresponding sides. So when we're looking for the sine of angle A, we could look at the sine of angle A in the small triangle. We can also look at sine of angle A in the big triangle, since angle A is congruent to angle A, and the sides are proportional because we have similar triangles. So the ratio should be the same for both sine of angle A's, no matter if it's in the small or the big triangle. So let's start with the small triangle. So remember, sine is O over H. So in the small triangle, O would be BC and H would be AB. In the big triangle, O, opposite from angle A, would be DE. And H would be the whole hypotenuse of the big triangle, which would be AD. I'm looking at which answer choices matches up to either one of these. Both of these are valid. And I see it's the one from the small triangle that's listed here. Okay, let's take a look over here. So we have a rectangle. And AS is perpendicular to LN. That means it forms right angles where it meets LN. So I'll erase this right here because I don't want it to be a little confusing to see it. But I put this right angle in because we have a rectangle. And remember, all four angles of a rectangle are 90-degree angles. So what we have here is we have a big right triangle with an altitude drawn to its hypotenuse. Now remember, anytime we have the situation with big right triangle with an altitude drawn to the hypotenuse, we're going to think either leg rule or altitude rule, right triangle altitude theorem. So remember, when you have big triangle with two smaller right triangles inside. So we're looking at the answer choices and we're trying to see which is correctly set up for leg rule or altitude rule. If you don't remember what those are, there is a video on those. Check it out. It's under Geometry Resources on Google Classroom. Click on the document with all the video links and you can find it there. So let me take a look. In number 1, AS is getting repeated twice. And when we cross multiply, it will get multiplied by itself. So that's the mean proportional. And that's the altitude. So if this one's correctly set up, it's going to be using the altitude rule. So it is true that in the altitude rule, the altitude gets written twice so that it's multiplied by itself. Let's write down the rest of the altitude rule. The altitude is the mean proportional between each part of the hypotenuse of the big right triangle. So on the big right triangle over here, LS is one part of the hypotenuse, and S or SN is the other part of the hypotenuse. So these should be in the two other spots in the proportion if it's set up correctly. And look, LS is there and SN is there. So this one is correct. But let's talk about why the other ones are not. So in the next one, nothing is getting written twice and multiplied by itself. So nothing here is written as the mean proportional. Remember, leg rule and altitude rule has something that's written twice and multiplied by itself. In the altitude rule, it's the altitude, that's the mean proportional. And in the leg rule, it's the leg, that's the mean proportional. That's why it's called altitude rule and leg rule. Okay, here, I don't have to really look too much. AS is written twice, but it's not written so that when we cross multiply, it would get multiplied by itself. AS would get multiplied by LS. AS would get multiplied by SN. But AS is supposed to be multiplied by AS, if that's the altitude. It should be written twice and multiplied by itself. And then finally, taking a look at number 4, LS is getting multiplied by itself, and it's written twice. But LS is just part of the hypotenuse of the big right triangle. So that's good, because it's part of the hypotenuse, but that should be other part of the hypotenuse. And the other part of the hypotenuse is SN. The altitude is the mean proportional. So the altitude is what should be multiplied by itself and written twice, and that would be AS. But AS is not written twice here, so that's not correctly set up. So number 1 is the only one that has a correctly set up proportion, a correctly set up altitude rule. Okay, here we don't have a right triangle. 50, 80, that's 100 degrees, it's not 90. So we can't use a trig ratio. What we're going to have to use here is law of sines. So let me set up my law of sines. So sine of an angle over the side across from it equals to sine of a different angle over the side across from it. I'm looking for AB. I'm going to call that X. So I want AB to be in my proportion because I'm looking for it. And the angle opposite from AB is the 50-degree angle. Now, the only other side I have is the 13, and the angle across from the 13 is 100. Some people were using cosines or tangents. It's law of sines. It uses sine in it. It's called law of sines. Okay, let's cross multiply. We have 13 sine of 150 is equal to x sine of 100. Then to get the x by itself, we just need to divide both sides by sine of 100. So we have x is equal to 3 sine of 150 divided by 13 sine of 150 divided by sine of 100. If you type that into your calculator, you should get approximately 10.1 to the nearest tenth. For the next question, remember sine and cosine. Listen to the name. Sine and cosine are cofunctions. That means that they're equal when their angles are complementary, when their angles add up to 90 degrees. So once again, sine and cosine are equal when their angles add up to 90 degrees. So we need to take their angles and equal them to 90 degrees. Couple more steps. But it's asking for the measure of the smaller angle. It's not asking for the x value. So the angle for the sine is 4x. So 4 times 11 is 44. And the angle for the cosine is 3x plus 13. So that's 33 plus 13. That's 47. So the smaller angle is 44. It was the 4x angle. Okay, moving along. Here we have a rectangle, and rectangles have 90-degree corner angles. So this angle has no choice to be 60, and this one has no choice but to be 30, and that leaves this one with no choice but to be 60. So what we have here are two 30, 60, 90 triangles. And 30, 60, 90 triangles have sides that are in the ratio 1 to radical 3 to 2. Now, the 12 is across from the 90-degree angle. So that's the biggest side because it's across from the biggest angle in the triangle. And we can just pick one of the 30, 60, 90 triangles to focus on. They're exactly the same. Two of the same 30, 60, 90 triangles. So the 12 is the 2 part of the ratio. It's the largest side. So to get from the largest to the smallest, all we have to do is divide by 2. Because remember, the smallest and the largest are in the 1 to 2 relationship. So from small to large, we multiply by 2. From large to small, we divide by 2. So the smallest side is 6. And remember, the smallest side is located across from the smallest angle. So that would be across from the 30-degree angle. We have that side is 6. Just one more side to go. We just need side BC over here. And that's the side across from the middle biggest angle. So to get from the smallest side to the middle biggest side, which is across from the middle biggest angle, all we have to do is multiply by radical 3. So we have 6 radical 3. And remember, opposite sides of a rectangle are congruent. It has all of those nice parallelogram properties. So we're finding the perimeter. So we have 6 plus 6 plus 6 radical 3 plus 6 radical 3. Now the question does say to round to the nearest tenth, so I am going to stick this into my calculator. 6 plus 6 plus 6 radical 3 plus 6 radical 3, and I got 32.784. It says to the nearest tenth, so that's approximately 32.8 for the perimeter. Okay. This question's asking for the area of the parallelogram. So we have a parallelogram, And we all know that a parallelogram can be divided into two triangles, right, by a diagonal. So we really have two triangles here. We know how to find the area of a triangle. The sides of a parallelogram are 6 feet and 8 feet. Doesn't matter which one goes where. Remember, in a parallelogram, opposite sides are congruent, so we do know all the sides. And the included angle is 150 degrees. That means the angle in between the two sides. And remember, opposite angles are congruent in a parallelogram. So we have two triangles here, and they're exactly the same. So we just need to find the area of one of the triangles and then double it, multiply it by 2 to get the area of the whole parallelogram. Now, these triangles are not right triangles. They don't have a 90-degree angle. So I don't know what the height of this triangle is. Remember that height is an altitude, a perpendicular line. So if we don't have a 90-degree angle, if we don't have a perpendicular line here, the altitude, we're not really going to be able to tell what the height of the triangles is. So we're not really going to use our normal area of a triangle formula because we don't have the height. If we had the height, we can go right ahead and use it. It would make our life a lot easier probably, but we don't have the height, so I can't use that. It's not an option for me. Instead, what I notice is I have two sides next to each other and the angle in between. And we know that when we have two sides next to each other and the angle in between, kind of like SAS, we can use our new area of a triangle formula that uses trig. And remember that formula is 1/2 AB sine of angle C. Now, just to refresh your memory, the A and the B, they're lowercase, they stand for sides, and they just mean two sides next to each other in your triangle. So the two sides next to each other that I have are the 8 and the 6. And then we need the sine of angle C, and remember, angle C just means the angle in between those two sides. That would be 150 degrees. Now, in my calculator, I'm just going to type this in, 1/2 times 8 times 6 times, oops, I messed up in my calculator. Let me try that again. 1/2, 6, 8, sine of 150. And I got 12 for the area. And remember, this is the area of a triangle formula, so that gave us the area of one of the triangles. So since there are two triangles, our area is 24 square feet. The units here are feet. Okay, we have the diagonal of a square. So here's my square, and the diagonal is 20 centimeters. And remember, squares have all 90-degree angles, but even more than that, a square is also a rhombus. So the diagonals bisect the angles. So 90 cut in half is 45. So we have 45, 45, 90 triangles here. And remember, 45, 45, 90 triangles do come from squares. So we have two 45, 45, 90 triangles here. Let's just focus on one of them since they're exactly the same. And the ratio of the sides of a 45, 45, 90 triangle are 1 to 1 to radical 2. The two legs are the same, and the hypotenuse is radical 2 times bigger. The 20 that we have here is the hypotenuse. It is the side across from the biggest angle, the 90-degree angle. So that is the hypotenuse. It is the radical 2 part of the ratio. So to get from the hypotenuse to the legs, we have to divide by radical 2. So I'm going to take 20 and I'm going to divide it by radical 2. Now remember, we can't leave a radical in the denominator, so I'm going to rationalize the denominator by multiplying the top and the bottom by the radical that we want to get rid of from the denominator. So on the top, we have 20 times radical 2, that's 20 radical 2, and radical 2 times radical 2 is radical 4, which is just 2. 20 over 2 divides evenly because we divide coefficients, so we have 10 radical 2. Now that is each one of the legs of this right triangle, of this 45, 45, 90 triangle. And remember, squares have all equal sides. So all of the sides are 10 radical 2. All we need to do is multiply by 4 to get the perimeter of the squares and sides. And remember, we just multiply coefficients. So 10 times 4 is 40 radical 2. So the perimeter is 40 radical 2 centimeters. Okay, moving down. Notice big right triangle with an altitude drawn to its hypotenuse. So big right triangle with two smaller right triangles inside. Right triangle altitude theorem, immediately think leg rule or altitude rule. It tells us from F to P is 12 miles and from E to M is 10 miles. Find the distance from M to P. So we're looking for the section over here. That is what we're looking for. I just labeled it as X. The big thing a lot of people were doing was assuming this was a 45, 45, 90 triangle. There is absolutely no reason to believe that. We are not starting with a square. We have no reason to believe that this angle is being bisected or that this angle should also be 45 degrees. There is nothing that says that. So based on the fact that we don't have the altitude and we're not looking for the altitude, I'm going to throw the altitude rule out the window. Leg rule is what we're going to use. And in fact, we do have this leg of the big right triangle. These are the legs. This is the hypotenuse. And we do have this leg is 12. So to refresh on what the leg rule says, the leg rule says that each leg of the big right triangle is the mean proportional. So it gets written twice and multiplied by itself between the whole hypotenuse and the part of the hypotenuse directly below the leg that you are using. So let's set this up. So the leg that we have is 12, so that needs to get written twice so that it's multiplied by itself. And it's the mean proportional between the whole hypotenuse, which is the 10 part, plus the x part, and the part of the hypotenuse directly below the leg we're using. So that would be the x. Cross multiply it. We have x times 10 plus x equals to 144. Remember to distribute. We have 10x plus x squared equals to 144. I'm going to subtract 144 from both sides so we can get this equal to 0. We have a quadratic. So I'm going to have to solve by factoring or quadratic formula, but I don't really like that when we can factor. So we have x squared plus 10x, just rewriting this part in standard form. And then I'm subtracting the 144 to make everything on the same side of the equal sign. So I'm looking for my factors of negative 144. So here's my A times CB chart. So A, C, and B. 1 times negative 144 is negative 44. So I'm looking for factors of negative 144 that add up to give me 10. So you can get this on your calculator if you go to your y equals and you type in negative 144 divided by x, not divided by x squared, that's radicals, negative 144 divided by x, and you hit second graph and you get your table of values. It will give you all the factors of negative 144. So all you have to do is scroll down your list until you find the two factors that also add to 10. So those factors end up being 18, negative 8. If you test that out right now on your calculator, 18 times negative 8 is negative 144, and 18 plus negative 8 is positive 10. So these are the factors that we're looking for. Let me draw an arrow over here. So our two factors are x plus 18 and x minus 8. Taking each one and setting it equal to 0, because remember the whole equation was equal to 0. So we have x is equal to negative 18 and x is equal to 8. In geometry, since we're working with real life objects, like here we're working with the diagram of a town, and it wouldn't make sense for the distance between streets in a town to be negative, we can generally always reject the negative if we get two solutions in geometry. So our x value is 8. So 8 is the distance between M and P. Now, if you set up the proportion correctly, but you couldn't factor, you couldn't solve, I just took off 1 point. But we should have recognized this is right triangle altitude theorem, either leg rule or altitude rule. Since we were not finding the altitude and we were not given anything about the altitude, there is only one option, and that option is the leg rule. Okay, so a person is measuring the angle of depression from the top of a wall. So here's the wall with the person at the top to a point on the ground. So this is going to be my ground. Now remember, the angle of depression is the angle at which the person is looking down at the object. So here's the person's line of sight. So the angle that they're looking down at the object at is actually outside of the right triangle. And remember, the angle of depression is always outside the right triangle. And the really helpful thing about the angle of depression is that it's alternate interior with the angle of elevation. So if you know the angle of depression, you also know the angle of elevation, which is inside the right triangle. And we can use that to set up our trig ratio in a little bit. It also says the point is located on level ground. So here's my level ground, 62 feet from the base of the wall. The base of the wall means the bottom. So if this is my wall, here's the bottom of the wall. So from the bottom of the wall on level ground to the point is 62 feet. Okay. I am looking for how high the wall is. So I'm looking for this length over here. So I'm going to label that X. I have my focus angle. From my focus angle, I'm looking for opposite because I want to find this length over here. And I'm given adjacent. I'm given the 62 feet. So if you write down your SOHCAHTOA and you look for which one uses opposite and adjacent, it would be tangent. So tangent, and remember, we need to include our focus angle in the parentheses because for opposite and adjacent, we wouldn't know what it was without that focus angle. And that's equal to X. That's what we're looking for. That's opposite over adjacent, which is 62 feet. From here, we're solving for a side, so we can put this over 1 and we can cross multiply. We have 62. Tangent of 52 equals to X, because X times 1 is just X. If I put this into my calculator, 62 tangent of 52, that is, and it says to round to the nearest tenth. If you didn't round according to the question, that was a rounding error, that was a point off. It's approximately 79.4. Okay. One more question to go and then the extra credit. So this one was exactly like one that was on the review sheet. And this one is given so much time after time on the Regents exam with diagrams looking exactly like this, just with different numbers and different situations. So the first thing I want to point out is that you can't use trig with triangles that are not right triangles. A lot of people were trying to set up trig ratios for triangles that are not right triangles, and that does not work. If your triangle is not a right triangle, you cannot use a trig ratio on it. Another thing that people were doing is they were setting up a trig ratio and using the 90-degree angle as their focus angle. You cannot focus on the 90-degree angle. You can focus on any other angle that you want, but you cannot focus on the 90-degree angle. So there's multiple ways to get the answer to this question, but I'm going to go through just one way. So over here, there are 2 right triangles. There is this small right triangle over here, and there is the whole big right triangle here. Now, unfortunately, the triangle here that has the angle that we want is not a right triangle. This is not a right angle. There is no reason to believe that that is a right angle. So since we don't know that this is a right triangle, we can't just use trig on it and get the answer directly. So we're going to have to use our right triangles to figure out what this angle is. Now, from the big right triangle, I can find out what this whole angle is, because that would be the whole angle in the big right triangle. And from this small right triangle over here, I can figure out what this angle is, because this angle would be in the small right triangle. And if I can find this big angle, in the small angle, I can subtract and I can be left over with theta, which is what I am looking for, the projection angle here. So let's see what I'm going to do. I'm going to start with the big right triangle. And I'm specifying right triangle because it is a right triangle. So I have this whole side, big right triangle, 72. And from the angle that I'm looking for, that would be opposite. And I also have the 75, that's the side of the big right triangle. And from the from the angle that I'm trying to find, this would be adjacent. So opposite over adjacent, that would be tangent. So I'm going to set up a tangent ratio, and I'll call this angle x that I'm looking for. Tangent of angle x is equal to opposite over adjacent. Remember, when we're solving for an angle, we can't just cross multiply. We have to get this angle out from being trapped inside tangent. So we're going to use inverse in order to untrap that angle. Now let me put this into my calculator. Second tangent, 72 over 75. And I get about 43.83. I want to leave a couple of decimal places until my very last step so I don't get a rounding error accidentally. Now, I'm going to go to my small right triangle. So I just found this angle. Now I'll find this one. I'm going to label it Y. So from angle Y that we're finding, we have this 12 that would be opposite, and we have this 75 that would be adjacent. So once again, tangent. Tangent of angle Y is equal to opposite, which is 12, over adjacent, which is 75. So here I have inverse tangent of 12 over 75, and that will give me that angle. So second tangent on my calculator, 12 divided by 75, and I get that Y is approximately 9.09. So I'm going to subtract the two. I'm going to do X minus Y, so 43.83 minus 9.09. Let me do that on my calculator. And the question does say to round to the nearest tenth. So the projection angle is approximately 34.7 degrees. If we do X minus Y, we're left over with the angle theta that we're actually looking for. Okay. Extra credit question I want to go over because it is a coordinate proof, which is always on the Regents exam. The past couple ones, it has been the one worth the most point. Now the 2-column proof has actually been a coordinate geometry proof. So remember, the format for coordinate geometry proofs are write down your formula that you're using, show all your work, and then end with a concluding statement. So in words, you actually do need to explain what your calculations show. And there's multiple different ways to correctly write this coordinate proof, but I'm just showing you one way, and I think it's the way that uses the least amount of work. So we do want to prove that ABCD is a parallelogram, but not a rectangle. So first, I'm going to start with proving it's a parallelogram. So what I did to prove it's a parallelogram is I found the slopes of each of the sides, and my goal was to show that both pairs of opposite sides were parallel, because I know that that is one of our ways of proving that we have a parallelogram. So I found the slope of AD and BC, which are opposite sides, and I found that they were both 5 over 2. And I found the slope of sides AB and DC, which are opposite sides, and I found that the slopes were both 3 over 8. So I ended with a concluding statement explaining what my calculation showed, what I was proving with my work. Since both pairs of opposite sides are parallel, the quadrilateral is a parallelogram. So parallelogram part is now done. The reason also that I use slope formula is to make my life easier with proving that it was a rectangle, because not only can we show sides are parallel using slope formula, but we can also tell if there's right angles or not using slope formula. Remember, if we have opposite reciprocal, also called negative reciprocal slopes, that means the sides are perpendicular, meaning that there are right angles. But if you take a look, my two numbers here were 5 over 2 and 3 over 8. And those don't look anything like each other. those are not negative reciprocals of each other. They don't really appear to have any relationship. So I wrote the concluding statement. I didn't have to redo the slope formulas because I already had them on my paper, but I did have to explain how the work that I had also shows that it's not a rectangle. So I wrote down, since none of the sides have negative reciprocal slopes, none of the sides are perpendicular, so there are no right angles. ABCD is not a rectangle because a rectangle is a parallelogram with right angles. So just remember, when you're writing a coordinate proof, you need to show all your work, and you also need to explain in words what your calculation showed. It is points off if you don't have your concluding statement, your explanation in words. The Regents exam actually takes a lot of points off. If you don't have those, but you have all the work, you would only get half credit on the question, if even that. So it actually is worth a lot of points to explain in words what your calculations are showing. And if you found the slopes using rise over run, you can do that, but you have to write down what the slopes are. You can't just write a concluding statement. Even if you just counted the boxes and did rise over run, you have to actually write down what the slopes are. Even if you don't plug into the formula, just write down slope of AD 5 over 2, slope of AB 3 over 8, and so on. Write down what the slopes are. So that way, I know that you did work to get it, and also on the Regents exam, they know you did work. On the Regents exam, a correct answer with no work is only worth 1